Dear students, this problem is taken from real numbers. The problem is show that one and only one out of n or n plus 2 or n plus 4 is divisible by 3 where n is any positive integer. So here goes the problem, and please recollect Euclid's division lemma, division algorithm. A is equal to BQ plus R, where 0 is less than equal to R less than B. That is most important here, and we shall see. Consider solution for this. A little lengthy answer will be there, but each statement is very important. We will have to write it very carefully. Uh, consider any two consider any two positive integers a and b such that a is greater than b, then according to Euclid's division algorithm, a is equal to bq plus r, where q and r are positive integers and 0 less than or equal to or less than b. This statement is very important in solution to this problem. Without writing this, don't ever try to go to the next level. Here, let a is equal to let a is equal to n and b is equal to 3. Why? Because in the question it is divisible by 3. That means it should be 3. B is equal to 3, and hence R should be less than 3. That is, it can be 0 or it can be 1 or it can be 2. Fine. Then we get A is equal to BQ plus R. A is equal to BQ plus R can be rewritten as A is equal to N, and B is nothing but 3. Therefore, we will write as 3Q plus R. This is a very important statement in this. N is equal to 3Q plus R, where R is either 0 or 1 or 2. Now we will discuss all these three cases pertaining to this equation. If R is equal to 0, then N is equal to 3Q plus R, that is N is equal to 3Q plus 0, that's equal to 3Q. And N is equal to 3Q, and 3Q is divisible by 3 because it is containing 3. Well, that is N is divisible by 3. This one is now proved. Let us now take the next one, that is When r is equal to 0, if r is equal to 0, then n is equal to 3, sorry, r is equal to, we have to take the next one, that is 1, 3q plus 1. But what we require is, it is to be n plus 2 here. Therefore, we will have to go to the question. N is over, now it is n plus 2. We'll have to take that into account, and here it becomes n is equal to so much. Therefore, I write n plus 2 is equal to 3q plus 1 plus 2. That is n plus 2 is equal to 3q plus 3, because 3q plus 1 plus 2. That is 3 is taken common, q plus 1, and hence it contains 3, and therefore n plus 2 is divisible by 3. This implies n plus 2 is divisible by 3. And finally, if r is equal to 2, we take n is equal to 3q plus 1. But in this case, we need to discuss whether it is n plus 4. We'll have to see this. Therefore, we will go for adding n plus 4 to this. We have n plus 4 is equal to 3q plus 1 plus 4. 3q plus 1, 3q plus r is equal to 2 here. Therefore, we will write it as 2. That is n plus 4 is equal to 3q plus 6. That is equal to 3 is again taken common, that is q plus 2, and hence n plus 4 is also divisible by 3. Finally, we say that n plus 4 is divisible by 3. Therefore, you have proved that either show that one and only, read the question again. Your question says, show that one and only one out of n or n plus 2 or n plus 4 is divisible by 3. That is, you have proved that when r is equal to 0, n is divisible by 3 because it is containing a factor, multiple of 3. And n, if r is equal to n, then n plus 2 is again representing multiple of 3. And similarly, n plus 2 is divisible by, n plus 4 is divisible by 3 because it is again containing 3 as its multiple, and hence this is either it is divisible by n, or it is divisible by n plus 2, or it is divisible by n plus 4, and hence you have proved it.